Hey, it must be 2 hours UTC or at least very, very close. Got less than a minute to go until 2 hours UTC. Dun, 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 dun. I'm watching the clock. I'm watching the clock. Arrgh! Time goes so slow when you're watching it and goes by so fast when you're not. Dun, dun, dun. Was just watching the weekly space hangout. It was a good one. Ah, there we go. All right, 2 hours UTC. It is time for Astronomy Daily Live. This is a daily live stream coming at you from southeastern Arizona in the United States. Hope everybody's doing well. It's a little bit cloudy tonight, so yeah, boo hoo hoo on that. Haven't found or invented the cloud filter yet, so still working on that. Um, radio astronomers have it a lot easier because for the most part, I think these clouds uh, and the sun, at least daylight, isn't a problem for radio astronomers, but definitely daylight and clouds are a problem for pretty much everybody else. So yeah, a little cloudy here. Just tweeted out the fact that I am live, trying to bring in a nice crowd. So this is just a fun, casual get together of friends. It's like a circle of friends and getting together every single day. Turn off the TV, forget about the news, and let's focus on a common passion, and that is astronomy. Another thing that I'm completely passionate about is this amazing molecule. Uh, this one in particular is called hydrogen hydroxide, HOH, and it's absolutely fabulous. So cheers. I also have some coffee in the world famous thick thick rimmed mug. Can't tilt it much further than that, but you can see it's nice thick. Cheers to that. So yeah, I was just watching the weekly space hangout. Always an awesome show. If you don't know about that or haven't ever watched it, go over and watch it. They are absolutely awesome. Always talking about really cool things. Smart people, very smart. They know their shit, and even if they don't, they make it up really well, and they do a very good job faking it. So yeah, always exciting. They they were talking about these formations on Jupiter at the poles, and how surprising it all is, and don't have an explanation. And it's all I can say. It's all I can say, people, is that you have to think outside the box. Okay, don't keep thinking that you know what we've thought for the past 100 years or 200 years is how it is. Maybe there, maybe just a wild guess. Okay, maybe there's something that we're not considering. And the thing is that we don't know what we don't know. There's no way to know that, right? Except to think outside the box, change your perspective, consider every possibility. Every possibility. It doesn't matter how wild or crazy it is. The crazy stuff, the crazy stuff really needs to be looked at really hard because maybe it is crazy and maybe it isn't. You know, heard this crazy thing the other day about what was it? People getting into these weird looking contraptions and flying in the air. It's crazy, man. It's crazy. Heard about this other weird thing about the Earth going around the sun. Oh, I don't know. I don't know. It sure doesn't. In my little box, sure doesn't seem that way. So, people, you've got to expand your minds and think. You know, there's no way to break down the walls of the box. Okay, we all live in a box, but please let's expand it a little bit. Let's do science. Okay, don't you cannot rely on the tools of the past to help you discover new things. You have to use new tools, new thinking, new perspectives. So let's do it. Let's do it, and you know, uh, don't limit yourself to what you already know, because where the new stuff is stuff that you don't know, and we don't even know what we don't know, and yeah, that's why that's one of the reasons why science is so powerful, though, because it is this process fractal. Sort of the outputs go back into the inputs, and then it gets processed again. The outputs of that goes back into the inputs and get processed again. And that's a way. That's a way to figure out a lot of things. Um, but you can't box yourself in and say, okay, well, I'm going to limit the processing, and I'm going to limit the outputs, and I'm going to limit the inputs. It's like, no, 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 no. You've got to let things just happen. Just let things happen. So very, very exciting stuff. Anyway, huge shout out to the weekly space hangout. They've been doing this for years and years and years. They're very, very good, very um, um, smart, professional, and awesome. And this this live stream is a different kind of a thing, but I definitely um, aspire to that level. So yeah, probably someday I'll get there. So who knows? Cheers. So hope everybody's doing well tonight. I think there were a couple of things, and I need to get onto the chat here. In fact, I need to stop that. Uncle Bill is in the house. Bob Dog is in the house. Hope everything is going well with you. Cheers, cheers. Yeah, yeah. Hope hope you're getting some clear, maybe some warmer nights up there, Bob Dog. We've got let's see, uh, at least I'm still on March 7th. Um, so what is that? That's 2 weeks. 2 weeks from today is the spring equinox. In fact, let me share my screen, and we're going to go. I always, around this time of year, I always like to go and start finding out when exactly what time the equinox is. The equinoxes and the solstices for me are sort of my holidays. They're my favorite days of the year, and that's just because I'm an astronomer, and it's just a coincidental thing that these kinds of things happen. Um, but I'm sure glad they do. And let's see, 2018. I think I need to do equinox solstice because there's a Google or there's a Wikipedia page that's really really nice. So cannot type tonight. Solstice, the bad typing day. Let's see. Dun, dun, dun. There it is. Let's see what it says. So the spring equinox for 2018 happens on March 20th at 16:15 coordinated universal time. So it actually happens on the 20th. So we've got 13 days. 13 days until the equinox. Now, most people call that the beginning of spring. I sort of don't. I call that the midpoint of spring, just like I call the solstices midsummer and midwinter. Um, that's just, I guess, that's just a personal preference. You can call it whatever you want. Who cares? But that's just sort of how I see it. Is that you know March 20th is sort of mid spring because well. At least where I'm located, that is certainly the case. So the solstices, um, you know, June 21st this year, as you can see there, uh, that is definitely for me midsummer. Yeah, for sure, for sure. So yeah, so local time I've got to subtract 7 hours from that. So for me, it'll be 9:15 in the morning. So that's kind of cool. I always appreciate the 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 opportunity that I have to go out, and I will do this at 9:15 a.m. on March 20th, and I will glance at the sun, not necessarily stare at it. That's you know not necessarily a good idea, but definitely, maybe maybe photograph the sunrise, which would have just happened um, maybe a couple hours before that. So yeah, get a nice photograph of the equinox sunrise. That'd be very very cool. So yeah, equinox is always a great time of year. I look forward to all of these. Hey there, Tom. Glad you could stop in. Just talking about the um, equinox that is coming up, and you can see on your screen here that it's happening on the 20th this year at 16:15 UTC. I'm gonna go over to my smartphone and pull up my live stream over here so I can monitor monitor its progress, make sure that it's operational. Yeah, it looks like it is. So I hope everybody's doing well. So Uncle Bill is saying, consider thermal inertia. In my part of the world, it's coldest after the winter solstice. Um, yeah, yeah. I think it does depend on location, and my location definitely doesn't have sort of the extremes um, that other parts of the world does, and it's just because of the latitude. I live in the horse latitudes, and if you understand that reference, um, relatively close to the it's Cancer up here, isn't it? Yeah, yeah. Tropic of Cancer is at 23 and a half degrees north latitude, and I'm at about 32. So yeah, yeah. But yeah. Those 4 dates are probably my favorite days of the year. I guess I prefer the solstices over the equinoxes to a certain extent, but I like them all, and I sort of treat them um, as a holiday. So sometimes I um, um, take the day off, sometimes not. I've got a kitty on my lap who loves to play with these cables. I'm trying to prevent her from doing that, but I may have to. I may have to throw her out. All right. Well, cool. So huge shout out, as I said, to Weekly Space Hangout. They had a great show. I came in a little bit late and didn't see the whole thing, but I will definitely go back and watch the whole thing. They're always very very awesome. I also caught part of Dennis Hand's Periscope this week too. It must have been Monday when I saw that, and yeah, he's just um, doing his thing. He's been doing it for a few years now, I think. So, much far inland location as it is about latitude. Yeah, yeah, like about winter solstice is knowing that the days are getting longer. Yeah, yeah. I think I've got a friend who really 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 likes the winter solstice. Um, he usually throws so kind of a big party. We have a big bonfire and yeah, it's sort of a celebration of the sun because it's going to be coming back, and the days are going to be getting longer, and that's that's always nice. That's always nice. So yeah, I like them. I like them. So I think there were a couple of things that I wanted to do today, and hmm, I think I think I'm going to start with some work that I've been doing. As I said, I've got this interesting project that I can't give a lot of details about yet, but it does involve using the telescope and the CCD. And what I'm doing at the moment is I'm sort of uh, two big things. I'm characterizing, and look, I'll go back to not sharing, so I can pop back. Boing, boing. Where's it? Boing. There it is. um, so uh, one thing is to characterize this system. Just sort of see how how good or bad is it. Um, what are the limitations? All of that. I'm also learning a lot about um, how this scope works. You know how it tracks, how well it tracks, um, all of those things. I'm sort of trying to parameterize all of this. How well can I measure um, positions of of um, targets in the field of view? How well can I measure brightnesses? What are the limitations? What kind of tricks can I use, to push those, et cetera, et cetera, et cetera. Cheers. So what I thought I would do tonight is sort of go through a little bit of that with you. Um, and I guess probably the way to do that is to just show you some pictures. Let's see. So I think what we can do is we can start here with this, and what I'll do is I'll share my screen again. Share the screen again. Let me try. Let me pull up. Can I pull up two of these at the same time? Probably not. Let's see. What are we looking at here? That's not it. There it is. Okay. Okay, so this is an image that I took the other night of the region around M41. Um, M41 is a um, open cluster uh, just to the south of Sirius, the big bright star in Canis Major, and this is a very 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 small field of view. Okay, it's 12 arc minutes across and 8 arc minutes um, up and down, right? And I reversed everything here, so all the bright stars are black, and the sky is sort of this, grainy, grainy gray. And as you can see, pulling out pulling out quite a few faint stars. You can sort of see that there's these little halos around them, little halos. So that is a problem with focus that I'm still working on a little bit. Let me do that, and then we can zoom in a little bit more maybe. But this is just raw data, right? This hasn't been calibrated in any way. So you see all the artifacts, all these bad columns here. Some of these things in here are hot pixels that, yeah, just need to be removed. They they tend to mess with data a little bit, but you're seeing. So this is a filtered image. This is an image taken with a red filter um, for 1 second. It's a 1 second exposure, and you're seeing down to about 12th magnitude or so. These little faint little guys here. These are 12th magnitude stars. So that's not too bad for 1 second exposure with a filter that knocks out at least 2/3 of your light. So that's not too bad. Tracking isn't too bad. These are relatively round, but as I said, I've got some focus things to work on here. But what I can do is I can, and I've taken 20 or 30 of these, and I've added them all up. I've stacked them all up on top of one another and added them all up. And when I do that, let's see, is it this one? Nope, it's not that one. It's this one. I think it's this one. Is that the one we were just looking at? Let's find out. Let's go over here. I don't know why that's doing that. That's kind of weird. Uh-oh. It's having a conniption fit. Machines are so temperamental. I just want to fling them. All right, 41B, 41B. So that's a single frame. So now let's look for the stack. There it is. Is that the stack? No. Yep. So this is a stack of, I think, 30 of them. And what you see right away are all these funny looking. That's a result of the um, stacking, because the telescope um, doesn't track exactly when I try to just blindly add up 30 images. These things are all over the place. So what I have to do is I have to say, okay, um, And actually, I'm going to show you a few of the details here too. But what I have to do in this um, simplified case is I say, okay, I'm going to choose to uh, um, stack this star um, for each of the images. I'm going to stack this star, and what that means is that all the other stars will also stack. So for the first image, which say is that one, okay, I say, okay, I know where um, the location of this bright star is. So then when I look at the next one and it's moved a little bit, well, I can just take that second image and shift it so it exactly stacks on top of that one. And then I take the third image and I measure its shift, and then I shift it down. So it can be called shift and add, shift and add, shift and add. And I do this for 30 images in this case, and I end up with that instead. So you can sort of see that um, seeing a lot, well, at least the stars that are visible are a lot brighter. So you can sort of see there's that one, and then there's that. So you can sort of see this triangle of stars here. So, there's a bright, bright, faint. And then if you go over to the stacked one, say it's bright, bright, faint. But these are much brighter just because I've added up 30, 30 images. But as I said, these are just raw, um, not calibrated at all. So I haven't removed any of the bad pixels, bad rows, bad columns, and all that. So all that gets um, put into here too. So what you're actually seeing here, right, are bad pixels, but it's this shape because um, that's how sort of poorly the telescope was tracking. So you can see that it was slowly drifting around like that. I don't remember if it was going this way or this way, but yeah, the tracking drifts, and it isn't really consistent. It sort of goes all over the place. So yeah, a lot of useful information here. But the neat thing about stacking, right, is that you can see fainter targets. You see these two here, that one and that one. Okay, in the stacked image, they're pretty obvious. But if you go back to the original, single image, look at that. They're really not even there. That one's sort of there. That one, whoa, I've got to use my imagination to see that one. But that sort of goes for all these faint guys. Where is it? So let's see. Let's look at. Yeah, there aren't a lot of really faint stars here. Yeah, those are sort of the faintest ones. But yeah, so the stacking does a pretty good job, and this stacking is not ideal in any way. I just I wanted to get going on this, sort of see what I was up against in terms of all that. I'm seeing, and I'll show you some other um, um, images here uh, where it looks like there's some kind of rotation going on. Who knows? The other interesting thing that I'm seeing are these little tails going off to the side. I can't account for that yet. Not quite sure what's going on there. They're they're quite real. Um, they only, they're only really visible in the stacked uh, um, um, images, and they only sort of show up with the brighter stars. So I'm thinking it's something to do with how the CCD is being read out, and maybe these stars are a little bright. Maybe they're not saturating though. So yeah, I'm not quite sure what's going on there yet. But yeah, these are some of the things that you have to contend with if you're going to process um, um, astronomical images. So let's look at some other ones here. Let's see. Okay, so this is what we looked at. Um, that one. Okay, let's zoom out on these. So this is a different um, set of images. Same cluster. So this is M41 again, but this time I have no filters on it at all. So this again is a 1 second exposure, single frame, and with no filters at all. So in the previous images, the single filtered image, I was seeing down to about 12th magnitude or so, and the stacked, I was seeing down to about 14th. With this clear, the single image, I'm starting at about 14th um, magnitude. The faintest things here are about 14th magnitude or so. You can just sort of see, but as you can also see, they're a little fuzzy, which means they're out of focus. So focus is a tough nut, and it's all you can do is sort of your best. But I know that at least in this case, every single pixel on here is about um, 1 arc second in size, and I can probably estimate that my seeing was about 1 or 2 arc seconds, probably maybe even a little bit more than that, 2 or 3. So the best that I'm going to be able to do in terms of focus is maybe 2 or 3 pixels. But this is a lot more. We can here. Let me really zoom in on those faint guys, and you can see that they're pretty extended. They're pretty extended. They've got 6 or 7 across there, and you can sort of see it in these guys too. The centers here are um, um, overexposed a little bit, but you can definitely see a little fuzz around that. You see these? So definitely I need to work on focus a little bit. The one nice thing is that it looks like even with the tracking uh, being as it is, um, a 1 second exposure, I've got some pretty round targets. Not too bad. Not too bad. So I'm going to zoom back out here just to show the whole thing. So that's a single 1 second image, and as I said, I'm seeing down to about 14th magnitude or so. Um, but then I think I took 21 of these images, and I did the same kind of stacking, and I came up with that. So now we're starting to pull stars out that are 16th magnitude stars. So let's go back to that previous one. You see how this guy is just this sad little fuzz here, and maybe something here, right? But if I stack them, that really pops, and so does that one. maybe as an artifact, so it's not really coming up. But yeah, so you're starting to see a lot more stars, and you can see these little tails coming off of here again, going in a different direction. So I don't know what's going on with that. I have to understand that a little bit more. Now, this is the star that I decided, to center on or stack on. So I did exactly the same thing. I took the first image and I said, okay, I'm going to start right there. And then every subsequent image, I would sort of look around this star uh, or this region and see if I can find, you know, that star again. Because of the tracking, it will have moved. And so when I find it again, I shift the image and then I add it to the previous one. And so I did that for all, as I said, I think 21 pictures here. And when I did that for all of them, we get that. And that's pretty nice. But as you can see, for sure, I've got a focus problem here. The other interesting thing is that, see, the, sort of the further I move away from this guy, I'm starting to get what looks like a rotation thing here. So that I'm pretty sure is not an artifact of the tracking. It is an artifact of the algorithm that I'm um, um, using to do this shift and add stuff. It isn't subpixel. It's just um, pixel by pixel, and the peak can move around. So yeah, as I said, it's sort of a rudimentary um, piece of code at the moment. I'm going to show you the code here momentarily. Let's see, what else do I have? So this is just a sort of uh, um, quick look at the signal to noise. Let's see. So this is the filtered image that we saw before. So what I did is I took this guy. I'll zoom him up here a little bit. So I um, this plot that you saw is what's called a profile plot. It's just a plot of this row all the way across. So it just so happens to include that star right there. So I figured out, what row that was, and then I just did a line plot through there. And what you get is, whoop, zoom back out, is that. So here's my column number. Here is brightness. And you can see that, pretty noisy, pretty noisy. And here's that one star right there. So I'm I'm calling this about a signal to noise of maybe 2 to 1, 3 to 1, something like that. Still, workable, but yeah, sort of right at the edge of detectability. So then what I did is I looked at the stacked image. Is that this one? Yeah. And I looked at the same star, that one. So you can already see that it's much brighter. But I wanted to get, sort of a measure of what the signal to noise was there. And when I did that, this is the same profile plot. There's our star again. So you can see, get out of there, that the noise is way, way, way down here. And then signal from that star is nice and bright. So I'm I'm thinking here, I haven't done the calculation yet, but I'm thinking that this is at least 10 to 1. So that's not bad. That's not bad at all. Can't complain about that. So you can sort of see what or how stacking improves the signal to noise. And it's pretty obvious, when you look at the pictures here that things are much better, right? You can barely see it there, and it just pops out easily there. So yeah, stacking is a very, very powerful method. As I said, this is a rudimentary way of doing it. Let me uh, let me just show you the code that does the stacking. Now I write most of my um, image processing software in C. C is sort of my preferred language. So, and this isn't the editor that I use either. So it sort of doesn't look as nice as it could. If you know C, then you're not going to have a problem reading this. But if you don't, maybe it'll be a little bit confusing. Consider this, you know, just a look under the hood. Cheers. So a lot of times, what I do is I I just copy and paste code that I've already written. Sometimes I write libraries, but most of the time it's just a copy and paste because I want to do something fast and I don't want to have to change libraries and all that. So there's a lot of variables up here that I'm actually not using in the code, but this piece of code uses 5 arguments. They are defined as this argv variable here. So argv of 1 is my first variable, and then I've got argv of 2, argv of 3, argv of 4, and argv of 5. So argv of 1 is an ASCII list of file names. So as the comment says here, it's just a list of the images that I'm going to stack. Argv of 2 is the number of pixels in the x dimension. Argv of 3 is just the y dimension. And then argv of 4 and 5 is this initial position. So that would be, for instance, the location of that star. Okay, so I've got to have a starting point. It needs to know where um, um, the first one is. Now, a smarter code could actually go in here and find it on its own. I just wanted to do it fast, so it's like, okay, start here. that's that's a lot easier, a lot faster that way. These are um, 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 floating point arrays that I've allocated in memory. And then I've got this while loop. And all it's doing is it's reading in the the file name of, say, the first image, and it calls a function called read fits. And that's a function that just reads in um, um, the fits header and the fits data, and it puts it into this array that I'm calling uval1. It also, because of uh, well, yeah, it's got to swap around bytes because some programs write bytes in one order, and some programs write bytes in the reverse order. So in order to keep all that straight and make sure that the numbers are right, in this case, I have to swap them around. So if I'm looking at the first image, so I've got a variable called m, which is my image counter, I guess you can call it. If it's the first image, then it's all I'm doing here is I'm just got an array. It's a um, um, accumulation array, and I'm just setting these values to those like that. Let's see. So then, trying to remember this, it's a lot harder than it seems to actually describe what I'm doing in code. um, yeah. So this just accumulates the first image. The second image around, what it does is it looks for that peak, and that peak will have moved because um, um, the tracking uh, is different, and so it it needs to sort of look around a little bit and find that peak. And when it does that, it says, oh, okay, well, this is how much that peak has moved. So once we know how much that peak has moved, we can take the entire image, the entire second image, and shift it by a certain amount of x and a certain amount of y. And then I take that shifted image and I add it to the accumulation image. And then I set all the shift values back to 0. And then I just do that over and over again for every single image. And so this is the actual add part, and this is the shift part. So this is a shift and add. And this is just some diagnostic stuff. Um, this is the end of the while loop. This little curly brace up here. The beginning of the while loop is way up here, right there. Here's the beginning of the while loop, and here's the end of the while loop, right there. So when it's done, I just write the accumulation values out to a file, which I then convert to a FITS file, and I'm able to um, display it and make all the plots and everything else. Pretty simplistic piece of code at this point. But it produces that, and that's not too bad. Not too bad at all. As I said, I'm seeing 16th magnitude stars, which isn't too bad at all. Yeah, can't complain. Cheers. But of course, the devil is in the details. So there are a lot of details that I have to work out here. I've got to understand why I'm getting these little white tails. I've got to understand why I'm seeing rotation. I want to get. I actually want to measure the positions of these stars to see how the astrometry is. That's sort of one of the next tasks, is to see, um, if the positions of these stars match what's um, what's in the catalogs. So that is one of the next tasks on hand. So yeah, hope you like that. It's I'm gonna have to see if this is something that I can do. As I said, I think I've said this a couple of times that I've tried to watch um, some programming live streams on Twitch, and I don't know, it sort of drives me crazy. So I I don't know if I'm going to do this a lot or not. But let's see. We can go up and look at the peak finding function. So this function, I pass it um, the image. I pass it a starting point. I pass it pointers to where it finds a peak. What's val? I don't remember. I may not. I may not need val anymore. Where is val? Oh, okay. That's just the maximum value or the peak value that it finds, and then xs and ys are just the size of the picture. And so it's all it does is just a couple of loops here where it basically just says, okay, I'm gonna I'm gonna take x1 and y1 here, and I'm gonna draw a little box around it, and I'm gonna look at the pixel values inside of that box, and I'm gonna find the peak value inside of that box, and that could be in the center, it can be on the edge, it can be um, um, anywhere, depending on where the tracking um, um, left it. And so here's sort of the big thing. It's like, okay, so if the current value is greater than the maximum value, then it says, okay, well then that is a peak, right? Because it's actually higher than that. So I record the location of that peak, and I set the maximum value to that, and then I just loop around until I'm done, until I looked at all the pixels in the box, and when I'm done, I jump back down to my my main, and it says, okay, x2 and y2 are the locations of the current peak, and then it measures how far that peak has moved since the previous image, and then it does this shift, and shift shift is up here. Shift is even a little bit easier because it just um, yeah, wow, I'm gonna have to yeah, Tom, uh, if I were to have people um, work on this code, it it would definitely be commented. But because, haha, this is for my eyes only, there are no comments at all. Yeah, yeah. But yeah, I tend to uh, comment a lot when this code has to be used by somebody else. But if it's just me, I can read it and know exactly what's going on for sure. So yeah, I totally agree with you. Code needs to be commented like crazy, like crazy. But yeah, this just uh, it just looks at uh, the uh, the shifted image and the current image, and it does the shift. Very, very easy. And yeah, I think, you know, this this now is sort of a learning experience. I think if I'm going to be describing code and talking about it, I think I definitely want to um, comment it a little bit more, because then I'm not going to have to be, thinking about it sort of on the fly here. Uh, if I've got all the comments in there, then I can basically, you know, um, use those as notes. So it's a lot easier for me to, describe what I'm doing, as opposed to trying, to figure out on the fly what these things are doing. I just wrote this afternoon, or actually this morning, so it's pretty fresh still. But yeah, simple stuff, simple stuff. But the results are pretty good. Can't complain about that. Not too much, not yet. And yeah, the fact that I'm seeing 16th magnitude stars with a 1 second exposure, where the tracking is pretty good on that. Can't complain. So yeah, pretty happy with that. Pretty happy with that. Let's see. We're getting close to the end of the hour. Yeah, yeah. I totally agree about comments, for sure, for sure. This, threw together because I just wanted to see what was going to happen, with the stacking. Definitely, when I use this in the future, it'll be commented. Yeah. And as I said, this was sort of an experiment to see how how I would do, describing some code, and yeah, it's a little rough. It's a little rough. So it can probably only get better. Probably only get better. But all right, I think I'm going to get out of here for now. I'm trying to remember if there was anything else. Um, Keep looking for. I've got a new um, um, YouTube project that I'm working on. It'll be recorded stuff as opposed to live stuff. Don't get too excited about it, but it's something different. Don't know if it's going to work out or not. I need to actually um, do a recording and see how that goes. I think it might be moderately interesting. Um, yeah, we'll see how that goes. All right. Well, I think I'm going to get out of here for now, maybe a little bit early tonight. It has been fun. I like to, um, as I said, I'm trying to um, parameterize the capabilities of, of um, the system I have here for a pretty exciting project, and getting relatively close to I think being able to make that announcement, and yeah, I think it'll be kind of interesting, and yeah, kind of exciting. So all right, I think I'm going to get out of here for now. I'm a little tired. Don't know why. Little tired. So yeah, I think it's going to be an early night for me. Cheers. Hope everybody has a great day or a great evening. I will be back. I will be back in pretty much 23 hours. 23 hours from now, a mere 20 million kilometers in terms of motion. So yeah, just just over there somewhere. All right, I'm gonna get out of here for now. Got to go back up to the ship, and I will see you again on the spin. All right, take care. Bye.